Writing two-step equations. Okay, before we start with two-step equations, I want to go over a couple of vocabulary terms. An algebraic expression. Okay, an algebraic expression is an expression that contains at least one variable. Okay, an expression that contains at least one variable. Okay, and to list a few examples of an algebraic expression, see, x plus 8 would be an example. And also 4m plus 5. Okay? So before we get started into writing two-step equations, let's practice on writing some expressions. Okay, so here we have, the first one says the sum of a number and 75. Okay? We know that the sum, the word sum, means to add. The sum of a number. We don't know what that number is, so we can use any number, any letter, from A to Z. It does not matter. Normally, whenever we figure out, or whenever we use a variable, we always use the variable x. Okay? Doesn't necessarily have to be x. In this situation, I'm going to use the letter S. Okay? So the sum of a number, so a number that we don't know, so we place it with the variable. Sum of a number and 75. Okay, so the sum, we're adding the sum of a number and 75. Okay, the next one says the product of 3 and a number. The word product, as we know, means to multiply of 3 and a number. We don't know what that number is, so we can use any variable. So what I want you to do, I want you to give me an expression here. Okay? Equation. So now we have our algebraic expression, which is an expression that contains at least one variable. Expressions and equations are a little different. Okay? An equation is a mathematical sentence that shows that two expressions are equivalent or equal. So with an equation, we're actually going to have an equal sign. That's the difference between an expression and an equation. So an equation is a mathematical sentence that shows that two expressions are equivalent. Okay? In an equation, both sides have to be balanced. Okay? So I'm going to give you two examples of an equation. X plus 4 equals 7. Okay, what makes this an equation is the equal sign. Okay, if there was no equal sign there, it would just be an expression x plus 4. Okay, another equation would be 6 plus 1 equals 10 minus 3. Now you notice here that we don't have many variables in this equation, but it still makes it an equation because there is an equal sign. And like I said before, they have to balance out. So 6 plus 1 is 7. Okay, that's 7. And 10 minus 3 is 7. So you see on both sides of the equal sign, it is balanced out because they are equal. That's what makes it an equation. Okay. Now we're going to turn over on the inside and go to our first example. Writing two-step equations. Okay. Now, I want us to organize our work here. So we remember when we do the red light, yellow light, green light. We're going to stop and read our question. Then we want to yank out that important information. Then we're going to go solve our problem. Okay, so we have a taxi driver charges $3.25 for the first mile of a trip and $1.25 for each mile after that. He charges a customer $17 for a ride. We're going to write an equation that would help the customer find the distance she traveled in the taxi. Okay, so we're going to bear with me here because I'm going to give you time to write this down as well. But there are 3 steps that I want you to follow whenever you're trying to write an equation. So step 1, we're going to ask ourselves, what are we trying to find? So what are we trying to find? That's our question. So what are we trying to find? And that is going to be our variable. So our variable is what we're going to be trying to find. And we can use any letter for that. So we're trying to find the distance that she traveled. So we're going to answer that question by saying, we're going to let, and I'm going to use D because it's talking about distance. So we're going to let D be the distance. Sorry, that's not focusing there. The distance traveled. Here we go. All right. So step 1. What are we trying to find? Our variable. And we said we're going to let D equal the distance traveled. Okay. Step 2. Step 2 is this is where we use that yellow light. We're going to yank out that important information. So we need to identify the important information. Okay, so in our problem here, we know that the first mile charge is $3.25. Okay, so I'm going to write that down. The first mile charge is $3.25. Okay. Give you a minute to write that down. Okay. And we also know that it's $1.25 for an additional charge, mile charge of $1.25. Okay. So the additional mile charge is $1.25. It's a decimal there. And we're going to say times D because, remember we're trying to find our distance. Okay. And we also know it says that our total charges, he charges the customer, the taxi driver charges the customer a total of $17 for the ride. Okay. So we're going to say the total charges is $17. Okay, so now we stop our red light question. We've yanked out that important information. Okay, so now we're going to use the words in the problem to write the equation. That's going to be our step number 3. So step 3 is going to use the words in problem to write our equation. Okay. All right. So we know that we're just going to go through all of this. Our first mile charge was $3.25. So we're going to put that there. Okay. And we know we're going to have to add this. So plus the $1.25 and we know that's times the amount of miles traveled. So multiplication there. So times each mile, which we don't know, which we said that was going to be D, equals, and that's our equal sign. And we know that our total, $17. Okay, so what I want you to do here is to actually write that equation here. Okay, so for writing it, we want to step one, what are we trying to find? Identify that important information, yank it out, and use words in the problem to actually write the equation. Okay, now moving on to our second example, which is writing a verbal description of a two-step equation. So here it gives us the actual equation. We have to think about a real world situation to fit this equation. Okay, so what I want us to do is here, look at what we have. We have 80 minus 3x equals 53. Okay, so let's brainstorm down here. All right, so we know that 3x means that what we're looking for is multiplied by 3, because that x is that unknown value. So that 3x, we're going to say that means that what we're looking for is multiplied by 3. So whatever we're looking for is multiplied by 3. So keep that in mind. Okay. And we also know that here we start with 80. So that 80 means that we started out with 80, and then we're going to subtract 3 times whatever we're looking for. Okay. So we started, I'm going to write that down, just writing our thoughts here. We started with 80. And then we're going to subtract 3x. Okay. All right. So we know what that 3x means. I'm going to go over it again. It means that what we're looking for is multiplied by 3. And we started out with 80 of something. Okay. That equals 53. Stuck on 50. Equals 53. Means that after starting out with 80 and subtracting 3 times x, then we get a result of 53. Okay, so I'm going to write that down. I'm just going to write my thoughts down. So after starting with 80 and subtracting 3 times x, the end result gives me 53. Okay, let's go back over it. So 3x means that what we're looking for is multiplied by 3. So it's going to be 3 times something. We started out with 80, and we're going to subtract 3x. And that equals 53 means after starting with 80 and subtracting that 3 times x, the result is 53. Okay, so what comes to mind with me? I always think of money. Okay, so I'm going to start you out. I'm going to start you out with the real world problem, and then I want you to finish it for me, and we'll go over it in class. So I'm going to start out with Kendall had $80 in her bank account. Okay, now I started you out. She had $80 in her bank account. Now I want you to think of a scenario that you could write with that stem. I have $80 in my bank account. And what does that mean? 80 minus 3x equals 53. So I want you to fill that part out for me, and we'll go over that in class. Okay, so this is writing two-step equations.